In part 1 of the lesson series on how we should study, we ended the lesson with sleep, the role of sleep in the process. We saw that sleep does decrease retrieval strength. There's a delay. So we wake up the next morning and we might have forgotten some of the stuff we studied the night before. But hopefully, if we got good sleep, we did some system consolidation, which will boost storage strength. In time, sleep will not reduce retrieval strength because we will build up our storage strength to such a degree that we're not going to have this drop off in the retrieval strength. In general, spacing study sessions creates lower retrieval strength upon restudy, and this creates a difficulty that ends up being good for long-term retention. So again, if we just kept on studying, we would maintain our high retrieval strength, and we said that we run into the biological plasticity limit. That's no good for increasing storage strength. We want to allow retrieval strength to decrease and then restudy. In a sense, when retrieval strength diminishes, it's a kind of forgetting, but we want to look at forgetting as the friend of learning. Now, when we create a delay between study sessions, retrieval strength is weakened. Now, why is that again? Well, because the working memory boost is gone, so we don't enjoy the working memory boost because we've created the delay. Right? Only things that we've recently been studying are retained in the short-term memory system. In addition, as a result of sleep, we're weakening hippocampal synapses. That's part of the resetting process. So we're causing some decay of the memory trace here. So for these reasons, we're going to have weak retrieval after just one study session after a delay. But that's good. That's a desirable difficulty. Forgetting is the friend of learning. So we want to study when retrieval strength is low so that we can strengthen hippocampal synapses again and initiate more cortical consolidation. See, the next time we study, we're going to load up the information in our working memory. We're going to increase some synapses in the hippocampus. We'll do another round of consolidation, and that will lead to even stronger retrieval in time. So we get to consolidate again, and pretty soon our cortical memory traces are getting stronger and stronger. So the implication is we want to create delays in our study sessions. Studying when retrieval strength is low is a good strategy. It will lead to the greatest gains in storage strength. So spaced study sessions will be able to increase storage strength more than extending the original study session. So recall, if we keep on studying, we reach biological plasticity limits. If we create delays, if we space out our study sessions, we're forced to study again with low retrieval strength. That allows us to accumulate another round of system consolidation so we can boost storage strength. Now, why does spacing enhance long-term memory? Well, we've already encountered this concept. When we space out our study sessions sufficiently, we're getting multiple rounds of system consolidation. We can strengthen the cortical memory traces even more with more study sessions that are spaced out in time. If we were to look at this on our graph of storage strength versus rate of forgetting, when we space out our consolidation events, we're increasing storage strength, which will reduce the rate of forgetting. We don't want to pile up our study sessions back to back. That's kind of like a sort of a cramming situation. And again, it's the same idea. We think a long study session is good. It's not. Study sessions close in time do not permit separate consolidation events. Then the information is still temporarily stored in working memory, right? And we cannot increase storage strength when retrieval strength is already high. So we don't want to do that. We're going to end up with a high rate of forgetting. We have to increase our storage strength, and for that we need to space out our study sessions so that we get consolidation and synapse resetting in each delay period, and then we're going to be making the biological changes necessary to increase storage strength to make lasting memories. We will have a low rate of forgetting. If we think about cramming, something students often do, by definition, cramming is a single study episode just prior to an assessment, and as such, it cannot lead to large increases in storage strength because the brain has not gone through repeated retrievals and reconsolidations, which are the keys to long-term retention of information. The low storage strength after cramming means a higher rate of forgetting. So again, we can think of cramming as just sort of a single study session. It might be a long study session, but we know long study sessions are not very good. They lose their effectiveness. And because we have not boosted storage strength very much, we're going to have a fast rate of forgetting.